The name of this tutorial is ChildsPlay, creating a shape sorter. For this tutorial, we'll primarily be looking at compound object techniques that includes using Boolean commands and operands. We will use the ProBoolean tool primarily in 3ds Max. Along the way, we'll also explore the use of other helpful functions, features, and tools in 3ds Max for precise placement, quick duplication, and in general setting up our scene for efficient workflow. We'll be using primitive shapes primarily, as well as some of the essentials like using the transformation and navigation tools in the user interface of 3ds Max. To begin, we're going to find some reference. We'll do a quick search for shape sorter, and we'll filter our results to images only. Take a moment to browse through, select one or two images to use as inspiration or reference, and download to our local drive. And here's the image that I've selected for reference for this tutorial. Now to display our reference image while we work, we can use the View Image File function in 3ds Max found in the File menu. This will allow us to open our image in the secondary window that we can easily move out of the way or minimize while we work. To prepare the scene, we'll take a moment to set up the preferences. This can be found in the File menu toward the bottom. We'll access the General tab and look at the scene undo levels. By default, these are typically set rather low. I like to increase these significantly. Next, we'll look at the Files tab and take note of the number of autoback files that are saved. I've adjusted this up to 5, and the backup intervals I've kept at the default of 5 minutes. Next, we'll take a moment to set up the scene units. You can go to the Customize menu under Unit Setup. Under the Display Unit Scale, you want to be sure that Generic Units is active. Next, under the System Unit Setup, you want to set those to millimeter for this tutorial, and click OK on each window to confirm. Lastly, we'll take a moment to set up our snaps. You can access this by right-clicking the 3D Snaps icon in the ribbon. This will open the Grid and Snap Settings window. I like to use Vertex and Midpoint as my snap settings. Under the Options tab, I'll take note of the Angle Snap setting at 5 degrees. This option can be adjusted to make rotating with the angle snaps active a little quicker. I want to make sure that under Translation, the Enable Axis Constraints is active. Next, we'll start to make the sides of our sorter box. We'll begin with a chamfer box, which can be found in the Create tab or the Create menu under Extended Primitives. Once the chamfer box is started, we'll switch over to the Modify tab and adjust the parameters. There will be 6 total sides to the sorter box. We'll create these sides by cloning the current object and modifying the parameters of the duplicate. We'll repeat these steps a total of 5 times using the parameters seen here. Extending the modified panel to the left will reduce the need to scroll to see all of the available parameters for the current object. Here we will enter in the parameters according to the table for the bottom side of the sorter box. Once we've entered in the parameters, we'll adjust the transformations for this object. Using the Select and Move tool, we will place this object at the origin of the scene. This object will require no rotation values. With the Select and Move tool active, we can create a clone of the object by holding Shift, then clicking and dragging away from the current position of the object. In the Clone Options window, we'll select Copy as the type of clone. We'll keep the number of copies at 1, and then designate a name for the duplicate. Once the duplicate is created, we'll switch to the Modify tab and adjust the parameters for the object according to the values in the table. We'll repeat these steps for all of the duplicates, paying close attention to adjust the parameters according to the values listed in the table. Be sure to carefully monitor the rotation values for each object. Orienting the object so that they're laying flat will assist with the modeling process in the future. Before moving on to creating the shape blocks, we'll take a moment to organize the objects in the scene. For this, we'll use the Layer Manager, which can be found on the left side of the user interface in the same section as the Scene Selector. You may need to adjust the window so that the icons for the Layer Manager are visible. With all of the desired objects selected, click the Create New Layer button in the Layer Manager to organize the selected objects into the new layer. Next, we'll start creating the basic shape blocks. The majority of these objects will be based on a cylinder, which can be found in the Create tab under Standard Primitives. For the 7 cylinder-based objects, we'll use the parameters listed here in the table. Under the Create tab in the Geometry category, we'll select Cylinder and draw out a basic cylinder in the scene. Press the F4 key to activate the Edge Face mode. This will allow you to see the wireframe of the object superimposed over the solid surface in the display port. Next, we'll enter in the desired parameters for the cylinder. We'll call it Circle. We'll use 30 for the radius, 32 for the height segments and cap segments at 1, and 24 for the number of sides. Because each of these objects will have similar parameters, we can use the cloning technique once again. We'll drag out a duplicate of the cylinder we just created and adjust the parameters in the Modify tab. We can make subtle adjustments to the object's location to organize the objects as we create them. This will just keep them from overlapping as we go. We'll continue this process following the descriptions and parameters listed in the table. For the final 2 basic shape blocks, we'll use a box and a tube primitive, and we'll apply the parameters listed here. Again, we'll take a moment to organize these objects into a new layer. Next, we'll make some more complex shape objects using the compound object techniques in 3D Studio Max. Here, we'll take advantage of the ProBoolean tool. Boolean operations allow us to create a relationship between 2 or more 3D objects, resulting in a more complex 3D object. For the first of our more complex shape blocks, we'll start with a simple box. We'll adjust the parameters of the box according to the table. Length 60, width 20, height 32 or more, and the length, width, and height segments set to 1. Next, we'll need to make a clone of the object. However, rather than using the Shift and Transform method, we're going to use Ctrl-V or select Clone from the Edit menu. This will create the clone in the exact same position as the current object. Next, we'll rotate the duplicate 90 degrees, making sure not to move it from its location. Next, we'll combine the 2 shapes using the ProBoolean command. Navigate to the Create tab or the Create menu, locate Compound Objects, select ProBoolean. We'll use a union operation. We'll activate Start Picking and click on the unselected object. Once we've selected the object, we can press the Escape key to deactivate the Start Picking function. This will create a relationship between the 2 objects, resulting in the cross or X shape. Its current orientation looks like a cross. We can rotate the object 45 degrees on the Z-axis to give it the appearance of an X. When using Boolean operations, the object name is derived from the original selected object. Update the object name using the Modify panel. When done, we'll hide this object and start making the next shape block. Our next shape block will resemble an uppercase H. To create this, we'll start with the same base as the X or cross shape. We'll create a box using the parameters listed in the table. To complete the shape, we'll make 2 additional clones. We'll space these blocks out exactly 20 units, which is equivalent to the width parameter. There's a number of ways we can achieve this. We could use the absolute transform type in at the bottom of the screen, or we could take advantage of our 3D snaps. Use the S key to activate snaps. Remember, you can right-click on the 3D snaps icon to check the options for snaps. With midpoint and vertex snaps active, we can easily align the objects according to the edges or corner vertices. Aligning the corners of the objects using snaps will result in the objects being exactly 20 units apart. Repeat this step for the third object. Select and rotate the middle object 90 degrees so that it intersects with the two outer objects. You may find it helpful to detach the Compound Objects panel from the Create menu to make it easier to access. We will be using these commands frequently throughout this tutorial. I'll place the floating panel in the corner of the UI for easier access in the future. Using ProBoolean, unite the three objects into one singular, more complex object. This should complete the H shape. Rename the object using the Modify panel, and hide the object to move on to the next shape block. Our next shape block will be created using a combination of a box and several cylinders. We'll start by creating the box according to the parameters in the table, followed by the cylinder. We can create these quickly in the viewport and then adjust the parameters for each in the Modify panel. Next, we'll use the Align tool to accurately adjust the position of the small cylinder. With the object selected, use Alt-A to activate the Align tool, or click the icon for the Align tool in the ribbon. When using the Align tool, the first object selected is designated as the current object. The second object clicked after activating the Align tool is designated as the target object. Using the available options, first we'll align the small cylinder object to the center of the larger box object. We'll align the current object to the X, Y, and Z position of the target object using the available options. Be certain that center is selected for both the current and target objects. Use the Apply button rather than the OK button to confirm the options but to keep the window open. With the previous options cleared, adjust the Align Position options to either the X position or the Y position, and alternate between using the minimum and maximum under the Target Object column. This will move the small cylinder to the edges of the larger box. Next, we'll make several duplicates of the cylinder and repeat these steps to align the cylinders to all of the edges of the box. With all the cylinders in place aligned to the edges of the box object, we will use the ProBoolean to subtract the volume of the cylinders from the edges of the box and complete the new shape block. Update the object name using the Modify panel. When done, we'll hide this object and start making the next shape block. Our next object will be very similar to the last. Once again, it'll be based on a large box object, but instead of cylinders, we'll use several smaller box objects. We'll position the smaller boxes around the edges of the larger using the Alignment tool once again. Once the small boxes are in place, we'll use ProBoolean to subtract the volume of the smaller boxes from the larger box. As an alternative, try replacing two of the small boxes with cylinders. Or try rotating each of the small boxes by 45 degrees on the Z-axis before the subtraction operation. For our next shape block, we'll make an abstract cloud using several small cylinder objects. The radius for these cylinders can vary between about 12 and 16 units, but the height should be consistent. About 32 units should do. First, we'll make one cylinder and then create several clones using the Shift and Move technique. In the Clone Options window, adjust the number of copies to around 9 or 10. Next, using the Select and Move tool, adjust the position of each cylinder so that it overlaps with adjacent cylinders, and adjust the radius in the Modify panel. Once you're satisfied with the position of each cylinder, use the ProBoolean to unite all the cylinders into one object. And as usual, rename the new object using the Modify panel and hide the object in preparation for creating the next shape block. Our next shape block will be a 5-point star. We'll start with a cylinder with a radius of 32 units, height of 32 units, height segments and cap segments at 1, and we'll reduce the number of sides to 3 to make a triangular shape. Next, we'll scale the object down about 50% along one axis. Monitor the absolute transform type in fields at the bottom of the screen. This will indicate when the scale value reaches about 50%, indicated by the number 50 in the field for the corresponding axis. Next, we'll need to relocate the pivot for the object. Access the Hierarchy tab and click on Affect Pivot Only, or use the Insert button on your keyboard. We want to align the pivot along the short edge opposite the point of the triangle. Once the pivot is relocated, deactivate the Affect Pivot Only button or press the Insert button once again. Next, we'll make several duplicates of the object in a radial pattern using the Array tool. With the object selected, access the Array tool from the Tools menu. When using the Array tool, you'll find Activating Preview to be helpful. We'll want to make 5 total clones. Change the count value field next to 1D to 5. Next, adjust the value for rotate to 72 under the Z column in the incremental section. Click the OK button to confirm the array and close the window. With the new duplicate objects in place, select one of the objects, activate ProBoolean, and unite all the objects together. In the top view, rotate the object so that one of the points is aligned to the y-axis. Rename the object in the Modify panel, and hide the object in preparation for creating the next shape block. Our next shape block will resemble a crescent moon. We'll create this quickly using 2 nearly identical cylinders. We'll create the first cylinder according to the parameters in the table. We'll create a clone using the Shift and Transform method with the Select and Move tool active. We'll adjust the radius of the clone, and then we'll reposition the clone so that it overlaps the original slightly, but just off-center. With the original cylinder selected, we'll activate ProBoolean using the subtraction operation, and click on the second cylinder to remove its volume from the first. We'll rename the new object to finalize the new shape block. Our next shape block will resemble a sun. For this block, we'll combine several of the techniques used previously, including relocating an object's pivot, using the Align tool to center an object to another, and using the Array tool. To begin, we'll start with creating a large cylinder object according to the parameters in the table, followed by the smaller cylinder with 3 sides. Next, we'll use the Align tool to align the small cylinder to the larger cylinder according to each object's center. Next, we'll adjust the position of the smaller cylinder along one axis so that it overlaps with the outer edges of the larger cylinder. The side of the smaller cylinder should rest just inside the outer edge of the larger cylinder. Next, we'll reposition the pivot of the small cylinder to the center of the larger cylinder. With the small cylinder selected, we'll activate the Array tool. When using the Array tool, radial symmetry is accomplished by dividing the number of desired objects, that is the count, into 360 degrees. The result is the value in degrees for your incremental distribution. For this object, a count of 18 to 20 works well. Dividing 18, 19, or 20 into 360 will give us 18, 19, or 20 degrees of separation between each object. We'll place this value in the Rotate field under the Z column under the incremental section. With Preview active, we can see the results in our viewport. Once the desired object distribution is achieved, click OK to confirm the results of the array. This should distribute the small cylinders in a radial pattern along the entire circumference of the larger circle. With the large cylinder selected, activate ProBoolean and choose the union operation. Activate the Start Picking button and begin to click on the small cylinders that surround the larger cylinder. This process can be expedited using the Select by Name feature. Use the H key to access the Select by Name menu. Select all the remaining cylinder objects and press the Pick button to confirm. Once all the objects are combined, deactivate Start Picking and rename the object. Our next shape block will resemble a raindrop. This will be derived from 2 cylinders with similar parameters. We'll create one cylinder in the viewport and then quickly drag out a clone, then adjust the parameters for each cylinder according to the values in the table. According to the number of sides, one cylinder will remain round while the other will have a more triangular profile. Next, we'll position the triangular cylinder so that it overlaps with one edge of the round cylinder. This should give us the profile of a raindrop. We'll use the ProBoolean tool to unite these two objects. Lastly, we'll rotate the object by 90 degrees so that the point is aligned to the y-axis from the top view, then rename the object. Our final shape block will resemble a snowflake. We'll start with a small box and a cylinder. We'll adjust the parameters for each according to the values in the table. Next, using the Align tool, we'll first align the center of the cylinder object to the center of the box object. Here we'll use the Apply button to confirm the current align characteristics, but to clear the selections and keep the window open. Next, we'll adjust the Align options so that the center of the cylinder aligns to the minimum or maximum along the Y position of the box object. We'll click OK to confirm the align and close the window. Next, we'll unite these shapes using ProBoolean. We'll be using the Array tool to arrange clones of this object in a radial pattern. To prepare for this, we'll relocate the pivot to the short edge of the object opposite the position of the cylinder object before the union operation. Next, with the object selected, we'll activate the Array tool. We'll activate Preview, then adjust the count and the rotate value in the Z column as desired. 6 to 8 clones are recommended for this object. Remember, dividing the desired count number into 360 degrees will give you the rotation increment value. When done, confirm the array and close the window. Next, we'll use ProBoolean to unite all the objects into one, and then rename the object to finalize. Now that we're done creating all of our shape blocks, we'll take a few moments to arrange them into comprehensive groups. There should be enough shape blocks for each visible side of the sorter box to have 3 or 4 holes. We'll be excluding the bottom side as it is not visible. Each shape block will need to be duplicated. The duplicates will be used in subtraction operations for all of the sorter sides that are visible. Once the shape blocks have been arranged, unhide the sorter objects. From the top view, position the groups of shape sorter blocks onto the desired sorter side objects. Duplicates for the shape block objects could be made either before or after positioning them on the sorter box sides. Be sure to adjust the shape block's position on the Z-axis so that each block passes completely through the sorter objects. To begin the subtraction process, select one of the sorter objects, activate ProBoolean, change the operation to subtraction, activate Start Picking, and click on the corresponding shape block objects. Repeat these steps for the remaining 4 sides. Now that the holes are cut into the objects for our sorter, we'll look at positioning and orienting them correctly to form a box. We'll be referring to the values on this table to position the sorter objects. Note that the rotation value for each object is set to 0, 0, 0. You may recall that we set specific orientation values on each object when creating them initially. First, we'll double check that the bottom object is positioned at the origin. Activate the Select and Move tool and click on the bottom sorter object. Enter 0 for the X, Y, and Z axes using the absolute transform type-in at the bottom of the screen. Select one of the remaining 5 sorter objects, check the name, and enter the position values according to the table. Repeat this step for all the sorter objects. Once the position has been entered for all the sorter objects, we can rotate them all simultaneously by taking advantage of the Pivot Center feature. Locate the icon for the Pivot Center adjustment to the right of the Reference Coordinate System field in the ribbon. Be certain that Use Pivot Point Center is selected. This will allow the objects to be rotated by their individual pivots, rather than a centralized pivot based on the selection. With all the objects selected and the Select and Rotate tool active, enter 0 for the X, Y, and Z axes in the absolute transform type-in fields at the bottom of the screen. With the sorter objects in position creating the box, you'll notice some overlap with the edges. Next, we'll take steps to carve in detail to each side of the box to eliminate the overlap at the edges. It's recommended that you isolate each of the sorter objects as you work on detailing them individually. This will eliminate confusion and visual clutter while working. We'll create several box objects according to the parameters in this table. We'll position each of these boxes in a specific way and use a subtraction operation to remove parts of the sorter objects around the edges. Note that there are two sets of parameters for these box objects. We'll use the first set to remove parts of the bottom, top, front, and back sorter objects, and we'll use the second set on the two sides. Note that move and rotate each have 3 columns showing the X, Y, and Z values. Note that the name for each sorter object spans 2 or 4 rows. This indicates the number of boxes that you'll need for detailing. Start by creating the detail box that's designated for the bottom, top, front, and back sorter objects. Create a box in the viewport, and in the Modify panel, enter 16 for the length and width, 205 or more for the height, and 1 for the length, width, and height segments. Creating clones of this box during this workflow is recommended. Using the Select and Move tool, first position the object into place according to the values in the table. Once the detail boxes are in place for the corresponding sorter object, use a subtraction operation to remove the volume of the detail boxes from the sorter object. Repeat these steps for all of the sorter objects, according to the parameters and values provided in the table. Because we're working with the objects around the origin of the scene, you'll notice similarities in the values for each transform. Creating clones of the detail boxes in place using Ctrl-V and then changing the transform values for the X and Y axes will allow you to position objects quickly. For the side objects, we'll use a thinner box. We'll take a clone of the original detail box and adjust the length and width units to 8 in the Modify panel. We'll continue to make duplicates of the detail boxes and transform them according to the values in the table. Once again, we'll use ProBoolean set to subtraction to remove the volume of the detail boxes from the sorter object. For the second side object, I'll take advantage of the Extract Selected feature in the ProBoolean panel. This feature, set to copy or instance, will allow me to quickly make clones of operands that were used in the Boolean operations. I'll be using the operands from the sorter side 1 object. Although the object is currently hidden, I can select it using the Scene Sorter panel. With the object selected and the Modify panel active, I'll select the 4 detail boxes in the operands list. I'll use the Copy option and press the Extract Selected button to confirm. The objects will appear in the viewport exactly as they were positioned for the subtraction operation for side 1. Using this technique will save time when setting the transformations for the detail boxes for side 2. With the detail object boxes for side 2 in place, I'm ready to perform the Boolean operation. Here, I run into a problem. It seems that subtracting the volume of the last detail box causes the rest of the object to disappear. After double checking the transformation values for the detail box, I found that changing the operation order solves the problem. This is achieved by first selecting the desired operand from the list, then adjusting the number value in the field next to the Reorder Ops button, and then clicking the Reorder Ops button to confirm. With all of our objects created, it's now time to set up the scene. We'll want to position our shape blocks into a realistic arrangement around the sorter box. For newer users, this presents a great opportunity to continue practicing with the navigation and transformation tools in 3ds Max. Alternatively, we can take advantage of the Mass Effects features in 3ds Max. This feature will allow us to generate a physics-based simulation. To begin, we'll unhide all the objects in our scene and take some time to position the shape blocks above the sorter box. Increasing the height of the blocks above the sorter box will allow them to pick up speed as they fall through simulated gravity. Next, we'll set the characteristics for the objects for the simulation. To do so, we'll need to access the Mass Effects toolbar. We can find these tools under the Animation menu, or we can access the Ribbon tools by right-clicking on an empty spot on the ribbon, then selecting Mass Effects toolbar from the drop-down menu. Locate the Mass Effects toolbar in the ribbon, and take a moment to familiarize yourself with the icons. The second icon from the left allows you to set the properties for rigid bodies. Click and hold on the icon to reveal the available options for rigid bodies. Rigid bodies can be set as dynamic, kinematic, or static. For this simulation, we'll set the sorter objects to static rigid bodies and the shape blocks to dynamic rigid bodies. Use the play button in the toolbar to run the simulation. To observe the results of the simulation, you can use the rewind button to reset the simulation. This will bring the objects back to their original position. making subtle changes to the position of the shape blocks before the simulation will give different results for their ending position. This concludes the Child's Play Creating a Shape Sorter tutorial. I hope you've enjoyed, and thank you for watching.